Okay, so this video is section 8.2 part 2, motion problems. So we're going to be looking at the motion problems along a line such as the x-axis. We know that from before. We're going to be using the vector approach, which is similar to the parametric approach to things. So they're one and the same. So we recall that the motion of a particle along a line such as the x-axis, we know that our position function, x of t, they can use different notation here, but x of t. The velocity function is the derivative of the position, and the acceleration is the derivative of the velocity and the second derivative of the position. So this is the stuff we know. We also know that displacement is the integration between two time values of the velocity. The new position, so x at a new position, new time, is the initial time position, the position at the initial time, plus the displacement. And the total distance traveled is the integration between two time values of the speed, and the speed is the absolute value of the velocity. So this is the stuff that we know. In vector value functions, when t represents time, the vector value function represents motion along a curve. Okay? So then we have these items. Very similar, but the position vector, right here. The velocity vector, which is the derivative of the position vector. So x prime, y prime. The acceleration vector, same approach, is very similar. See what's happening here. The displacement is the integration of the velocity vector, which is the integration of each of those two items in there. And the total distance traveled along a curve, you'll notice that this is very similar to this is exactly what we talked about in the previous lesson, where we had the length along a curve. This is what it is right here. It's basically the total distance traveled on a curve. So this is that dx dt squared, dy dt squared, but in this case it's vector format. And this is the magnitude of the vector v. Okay? The speed of the particle, or the magnitude of v, you can see is that formula right there. Okay? These are all the things that you're going to want to make sure that you know, so that we can answer the questions that are coming. And this is, so we are moving along a curve in the xy plane. We need to think of the particle moving with an x direction and a y direction. These may also be presented as parametric equations. So again, vector valued functions and parametric equations are literally one and the same. So we're going to use these formulas to answer some questions. And let me go ahead and pull up the first example. So there we go. For time t greater than 0, the position of a particle moving in the xy plane is given by this vector. Find the velocity and acceleration vectors. Okay? So, very simple. We already know how to do this from previous work. We're just adapting it to the vector format. So the velocity vector is the derivative of the position vector. And that just simply means I take the derivative of each piece. So the derivative of this with respect to t, 8t, 5 e to the negative t. It's not negative t. I don't want to have a negative there. Sorry. To the t. And then the derivative of this piece. 6t squared. Drew the sine as a cosine. And make sure you write it in vector format. The acceleration vector is the derivative of the velocity vector, which is this right here, which we can also write as the derivative, the second derivative of the position vector. So let's take the derivative of this thing, and you simply get 8, 5e to the t, and this one will be 12t plus the sine of t. And there you go. It is that simple. All right, let's look at the next example. For time greater than 0, the position of the particle moving in the xy plane is given by some parametric format. For t greater than 0, dx dt is this, dy dt is that. Find the acceleration vector and speed of the particle at the time t equals 2.5. So we want to find the acceleration vector and the speed. Okay, so the acceleration vector is the derivative of the velocity, so we have to find the velocity vector, which we are basically given. So v of t is 5t squared plus 3 and t times the sine of 1.2 times t. That and that in there. So the acceleration vector is the derivative of the velocity vector. And so we just need to take the derivative of this piece right here. Okay? And so we get what? 10t. And then over here we have a product rule, t and sine of 1.2t. So it is the first times the derivative of the second times 1.2, and then plus the second times the derivative of the first, which is 1. So that is the acceleration vector, and we want to find that value at 2.5. So just literally just plug it all in. So if I plug it in and work it out, I'm not going to plug it in and then work it out. If I plug it in and times everything out, 10 times 2.5 is 25. And you can check this out yourself. Plug in 2.5 into this expression right here and evaluate it, and you're going to get an approximation of negative 2.829. I'll leave that for you to check the math on your calculator. Okay. The second part of this question was to find the speed. The formula for the speed, remember, is the magnitude of vector v, and it is the square root of x prime of t squared, y prime of t squared. So at t equals 2.5, my speed is going to be the square root of x prime of 2.5 squared, y prime of 2.5 squared. And then we can use our calculator and find an approximate value for this. So just plug 2.5 into each of these things up in here. Oops, sorry, you couldn't see that. And get this value. So double check the math, make sure I did all those right when you plug it in. Here's another problem right here. I'm going to move it up here so you can see it. A particle moves on a plane curve so that at any time t greater than 0, its x-coordinate is t cubed minus t, and its y-coordinate is the quantity 2t minus 1 cubed. The acceleration vector of the particle at t equals 1 is what? Okay, so a particle moves on this curve. That means they gave me r. So the vector r of t is x of t, y of t, and that is t cubed minus t and 2t minus 1 cubed. So that is r. Okay, move it down here so you can see the rest of the page this time. So we want to find the vector, the velocity vector, which is the derivative, which is going to be 3t squared minus 1 and 2t minus 1 squared, and then we times the inside here, which will be 2. Okay? And you can clean this up, especially the back side over here. And this gives me 6 2t minus 1 squared. And now we can take find the acceleration vector. which is the derivative of the velocity vector, which is the second derivative of the position vector. Since you started with r, you should kind of tie it all together like this. It doesn't hurt to do it. Take the derivative of this, 6t, and take the derivative of this, is going to be 12 times that quantity, and then times the derivative of the inside, which is another 2. So it's going to be 12 times 2, and so you're going to get 24, 2t minus 1. So that's the acceleration vector, and they wanted us to find it when t was 1. So I now find this at 1. So it'll be 6 times 1, 24, 2 times 1 minus 1, and we get 6 in the front. This is a 1. You're going to get 24 in the back here, and you are done. Okay? So let's take a look. I have other examples. We're just running through all the different kinds of examples you might see on an AP exam that come through. So here is another one right here. Alright, so for t greater than 0, the position of the particle moving along the xy plane is given by this vector right here. Write an integral expression and find the total distance traveled on 1, 3. So we're trying to find the total distance traveled. Okay, so to start this off, you should always write out the formula that we have associated with this. We know that the total distance traveled, so the total distance traveled is a formula from A to B of the magnitude or speed vector. And then that is what? From A to B, x prime of t squared, t squared, dt. So this is my formula, so we just need to plug into it. So to plug into this formula, from the position of r, I need to find r prime, so I can get these x prime and y prime. So what is x prime of t? Well, it's the derivative of that quantity right there. And so that is going to be 8t plus 5e to the t. And what is y prime of t going to be? Well, that's the derivative of that right there, which is going to be 6t squared minus 7 cosine of t. And so these two quantities that I put in parentheses go in here and replace the stuff inside there. And so our total distance traveled on the interval 1 to 3 is going to be the integration from 1 to 3, 8t plus 5e to the t squared, and 6t squared minus 7 cosine of t squared dt. There's my integral expression. This is what they will be looking for to see that you have everything in here properly. So you want to make sure you know your formula. After that, this is a calculator exercise. You type all that in and you should get this answer for the total distance traveled. Okay, so practice that on the calculator. Make sure you can get all this and you get the right answer there. So this last one right here, I want you to try on your own. Well, it's not the last one, it is the next one. For time t greater than 0, the position of the particle moving in the xy plane is given by this right here. And dx dt is this, dy dt is that. So it's that same thing again. Find the displacement of the particle on this interval. And at t equals 1, the particle is at position negative 10, 3. Find the position of the particle at t equals 3. So these two items right here, this A and the B part right here, go ahead and pause this and try and work this out on your own before you continue on to see if you did it correctly. So So hopefully you paused it and you tried it out. Let's see how you did. So here is my first part, the displacement. My displacement, I always like to write the formula that I'm going to be using. From A to B is of the velocity vector. And to find the integration of the velocity vector, it simply means I'm going to take the integration of each of these things from A to B of y prime of t dt. So let's use our information to make this happen. So our displacement is going to be the integration from 1 to 3 of the velocity vector, which is going to be the integration from 1 to 3 of 5t squared plus 3 dt. See, they gave me x prime right there and y prime right there. And from 1 to 3 of t sine of 1.2t dt. And this is a total calculator exercise. As soon as you start seeing decimals in here, just go ahead and you start doing this. And this is a calculator one anyway. If you try to do it by hand, that's totally fine also. You can still get the answer. This would have been a little bit harder to do. Make sure you follow, if you do it, if you do these by hand, which they can happen that by hand, make sure you follow, use substitution techniques and all that kind of stuff. But if I use the calculator for this one right here, I should get 49 and repeated 3's. That's why this is an approximation. And then this one right here, 1.589. So hopefully you have that correct answer for part A. So in part B, they asked us to find a new position. So a position function, so x of the second time is the position at the first time plus the displacement from A to B of v of t dt. Okay, so what do I know? Well, I got to find x at 3. Okay, x at 3 is the position at 1 plus the displacement of x prime. Okay, and we know these values. They gave us this one. This number right here is -10. And we found this one right there. So this is approximately -10 plus 49.333 or 39.333. Well, what is y at 3? Well, that's y at 1 plus that displacement. And we know that y at 1 was 3, they gave it to us. And the displacement we found right here. And so we get 4.589. Don't leave your answer like this. Make sure you write it in the proper format at the end by answering the question they asked. Okay, find the position of the particle at t equals 3, and you write it out. The position of the particle when t equals 3 is 39.333, 4.589. You want to make sure that you write that statement out. Okay? So hopefully you got it right. If not, make sure we keep practicing and find out what you did wrong, and we go from there. Okay? I got the last example over here. And again, as I show it to you, see if you can do it. So let's go through the reading of it, and then I'm going to let you pause and see if you can figure all these out by yourself, okay? And then I'll come in and do them with you. At time equals 1, a particle moving in the xy plane is at this position right here, where x of t and y of t are not explicitly given. That means you don't know them. dx dt is this, dy dt is that. At time 0, x of 0 equals 0 and y of 0 equals negative 4. Find the speed of the particle when at time t equals 3, and find the acceleration vector of the particle at times t equals 3. So 2 parts to that one. Part B, find the position of the particle when t equals 3. And the last one, find the total distance traveled by the particle over the time interval from 0 to 3. All right, so go ahead and pause this out, see if you can do all these things that this lesson was about, and we'll come back and I'll show you all the solutions. Okay, so hopefully you paused it. Let's go ahead and start with part A. It asks for the speed, so write down your formula that you're going to use. It is the x prime of t quantity squared, y prime of t quantity squared. That is my speed. So we can plug these in, and I get my speed formula, which is going to be 4t plus 1 squared, and the sine of t squared squared. So at t equals 3, we're going to plug in 3 now. My speed is going to be 4 times 3 plus 1 squared, and the sine of 9 squared, and using a calculator, 13.007. So that's how that works. My acceleration, that's the acceleration vector, which is the derivative of the velocity vector. Okay? Which I have here as the derivative of this quantity right here, which is 4, and the derivative of this quantity right here, which is going to be, you can use a calculator too, so you could actually take this and find the derivative of this with a calculator. You don't have to find it by hand. Okay, that one was pretty straightforward. This one over here, we can try and do it. So it's what? The derivative sign is the cosine of t squared, and then chain rule, the derivative of that, which is 2t. So we have that. And so we want to find the acceleration vector at t equals 3. We can just simply plug in the values on our calculator. This will be a 4. And because we're using a calculator, it's approximation. Plug in 3 into that, and you're going to get 5.467. Double check my answer on your calculator. Hopefully you got it. And so there is my other solution right there. Okay? Let's look at part B. In part B, we want to find the position of the particle when t equals 3. Okay? So, what do I know? The x at the new time is x at the old time plus the displacement. And you can write it however you want. This is just one way of doing it. You can write x prime of t dt. You can do it as dx dt. Either way is fine. Because they gave me dx dt, I could have probably done it as dx dt and been totally fine. The y's new position is y's old position, t1, t2, and again y prime of t dt. So we're going to use both of those to figure this out. So here's x of 3 is x at 0, from 0 to 3, and then x prime is 4t plus 1. That was all given to us. And then y of 3 is y at 0, plus integration from 0 to 3, and this is the sine of t squared dt. Okay, you can try and do it by hand, but if it's a calculator exercise, please use the calculator. Do not do any of this stuff by hand. And so this right here is going to be 0. They gave us that. Remember, x of 0 is 0, and y of 0 is negative 4. So we have 0 plus, use a calculator for this, gives me 21. And so we have this to be 21. Here, this is going to be negative 4. and then use a calculator for this, rounding it off, you get 0.774. So y of 3 is negative 3.226. X of 3 is 21. And so then write your final answer is, at t equals 3, the particle is at position 21, negative 3.226. And that's part B. Okay? I'm going to have to flip this one over, so let's do the total distance. So part C, total distance is the formula from A to B in this big square root thing. Remember, dx dt squared dy dt squared dt. So my total distance, that's the formula, so the total distance traveled over 0 to 3 is 0 to 3, and then type all the stuff in that we had. 4t plus 1 squared, the sine of t squared squared dt. That's the expression. And then you use the calculator and approximate that out. So make sure you write both parts as you're doing this, okay? And so that ends that example, okay? And then here's a little side notes and stuff like that, just so you know, and I'll show you, you have everything that's right there. But down here at the bottom, they told us that it's very rare to see vector notation on the AP exam. Doesn't mean it's not going to be there, just kind of rare. Most likely it's going to be in the form of, parametric. The questions that are likely to be asked on the exam that involve vectors can be handled using knowledge of parametric equations. So the vector valued functions and the parametric functions are pretty much one and the same. The formulas were all the same. If you're dealing with vector stuff though, make sure you write your answer in vector form. Okay? And that's kind of like the difference. So that concludes this video right here, and see you on the next one.